All right, we're getting back to physics stuff here with the introduction to statics. Statics means, or like static means like it's not moving. It's static, not kinetic. So statics is the study of forces and their effects on a system in a state of rest or uniform motion. A state of rest, or actually uniform motion, just means a constant velocity. So you can be moving, but if you're not accelerating, then it's considered statics. And then, well, rest is also a constant velocity. It's just the velocity zero. So we're going to be looking at, well, like bridges and stuff, and things that aren't supposed to move. This is the study of things that are not supposed to move. Okay, that's why they're showing these pictures of lights, bridges, maybe the shelves. We are going to be looking a lot at forces and free body diagrams and stuff like that. So we'll consider Newton's first law of motion, and it says an object in a state of rest or uniform motion, meaning constant velocity, will continue to be so unless acted upon by a net force. What does that mean? That means if something is moving, it'll keep moving unless something else stops it. For us, since we live on Earth, we have an atmosphere, so a lot of that, like if you throw a ball, gravity and the atmosphere act upon the ball. Those are opposing forces, and it slows the ball down. But if you're in space and you threw a ball, it would just keep going and going and going and going at a constant velocity until it ran into something or something else pushed it in a different direction. So Newton's first law of motion: things will keep going unless there's an opposing force or a different force. Newton's second law says that the acceleration of an object is proportional to the net force acting on the object and inversely proportional to the object's mass. What does that mean? Well, to force, you can think of it like this. If you want to calculate a force, you have to know the mass of an object and the acceleration of an object. So, like, if I want to maybe like push a cart, and I want to know how much force I push the cart with, I need to know the acceleration of the cart in whatever direction I'm pushing it, and then also the mass of the cart, and then I can figure out the force behind it. Or, well, yeah, that's pretty much it. We're definitely going to use this a lot to calculate forces. So we'll need the mass and the acceleration of whatever object is, or whatever force. All right. And Newton's third law says for every action force, there's an equal and opposite reaction. So, like, if this animation was working, then you'd see the ball, like this metal ball, would hit this, transfer its kinetic energy through the balls, and then this one would move. Yeah, I mean, you've seen this before. That's just saying, if you do something to an object, there's going to be a reaction. So my 7th grade science teacher, when he showed us this, he would get somebody to stand on a roller chair, and he would say, okay, so for every action, there's an equal and opposite reaction. He had a kid stand on the chair, and then he would hold out a $20 bill, like maybe 4 feet away, and then say, all right, if you want this $20 bill, I'll let you have it if you can jump off the chair and grab it. And so the kid would jump off the chair, and the chair would just go flying backwards, because the kid, the silly kid, wanted to jump forward, but he's pushing back on the chair, and the chair isn't fixed, so the chair doesn't push back on him; it just goes backwards. So for every action, there's an equal and opposite reaction. That's what's happening. If you, like, when you're standing on the ground, the force of gravity is pushing you up against the ground, but then the ground is also pushing back. with an equal force. That's if you're in static equilibrium. So if you're not moving, then the force of gravity is counteracted by the force of whatever you're standing on. All right. Static equilibrium is when things aren't moving, and that's the whole point of statics. You're trying to build stuff that doesn't move. A condition where there is not a net, is not a net external force acting upon a particular or a particle or rigid body, and the body remains at rest and continues at a constant velocity. So things in space. Like if you threw something and there's no objects really close to you, then gravity's there. You don't have any gravity acting upon you. If that's moving at a constant velocity, then it's considered static equilibrium, or just like normal stuff here on Earth. If something's just not moving relative to the ground, then we can just say it's in static equilibrium. So all the forces acting upon it counteract each other. They all balance each other out. That's what they mean by net external forces. There's not a net external force. If there was a net external force, then you have maybe like unequal forces acting upon it, so that one of them overtakes the other, and then there's a net force, maybe pushing something in some direction. So yeah, static equilibrium is just when things don't move or move at a constant velocity, but we'll just think of it where things don't move. Continuing, translational equilibrium is the state in which there are no unbalanced forces acting on a body. It's on your entire body. And we'll consider the x direction, that's the horizontal direction. We'll often consider, on the regular xy plane, coordinate plane, the sum of the forces in the x direction would equal 0. So the translational equilibrium means all the forces acting horizontally oppose each other and they're equal. So that means when you add them up, you get 0. And all the forces acting up and down oppose each other, but they are also equal forces, so they add up to 0. That's what that's saying. If an object is in translational equilibrium, it's not moving, so all of the opposing forces in each direction, in the component's direction, x and y, then nothing moves. They got the picture. It's a balanced bridge. It's not moving. It works. You can walk on it. You can you could throw paper airplanes off it. You do whatever you want. But unbalanced bridge, somewhere along the way, some of the forces became unbalanced and it moved. And bridges aren't supposed to move. This guy was okay. I'm moving on. We'll continue in the next video. I think you should write down all these key terms. I mean, I think I should have told you in class. Static, these are all good key terms to know. So please have those written down. Yeah. Oh, rotational equilibrium. Okay.